Okay, now let's solve a few problem on rectangles and see what are the different scenarios that we get in this. So the length and the breadth of a rectangular room are 15 and then 8. So make a rectangular room here. This I'll draw it. 15 and then 8. So length and the breadth is 15 and then 8. I'll know the perimeter, I'll know the area. What is the perimeter? 2L plus 2B. So 2 into 15, 30. Plus 2 into 8, 16, which will be nothing but 46. That will be the perimeter of the room. Find the area of the floor, which means what? I have to paint this red part. I'll paint it and I'll have to find out the area of this, which will be nothing but length into breadth. So 15 into 8, which is 80 plus 8 5 is 40, 120. Okay, that will be the area of the floor. Now what next? Find the maximum possible length of the rod that can be put in the room. Okay, so what is the maximum possible length of the rod that can be put into this? So how will you go ahead with this? See, I'll have to make a line here which will be the diagonal. That will be the maximum possible length of the rod that can be put into this room, right? This will be nothing but the diagonal. So eventually he is asking me what is the length of this diagonal. So this angle in rectangle and this square, obviously it is what? 90. So what will I do? I'll apply Pythagoras theorem. So let the diagonal be x. So x square will be equal to what? 15 square, that is 225, plus 8 square, which is nothing but 64. So x square is equals to what? Add all of them, 229 plus 60, it's 289. So x turns out to be what? 17. So x turns out to be your 17, and that's the biggest possible length of the rod that can be put into this room. Okay, very simple problem on rectangle. Let's see one more problem. Length of the wall is 5 by 4 times its height. So there is a wall which has a length and then a height. The area of the wall be this. Find what is the sum of the length and the height of the wall. So again, this is a rectangle. It is just that the scenario in which it is being put in looks complicated. So say this is the wall and this is its length. This is its length, say L, and the height of this wall is nothing but h height. Okay, so this wall is nothing but forming a rectangle, and that's why it forms a problem on rectangle. So length of the wall is 5 by 4 times its height. This is what is given to me now. So from that, what will I come to know? I'll say L is equals to 5 by 4 of height. So let's write this L as 5 by 4 of height. Okay, now what will be the area? Area is nothing but length into breadth, which will be nothing but 5 by 4 of height into height, right? Because this is height. So what will this be? This is given to me 180. And if you just visualize what is this 180, this yellow part that we will be painting will be 180. So this is given to me as 180. So what will I do now? I'll just cut this. 5 1s are 5, 5 3s are 15. Then what am I left with is 30, 5 6 are 30. Okay, 36 into 4 will be nothing but h square. So h square will be equal to 36 into 4. Okay, don't solve this. You will be taking the square root. So h will be equal to square root of 36 into 4. So square root of 36 is 6, square root of 4 is 2. Okay, and so 6 into 2 will be nothing but 12. So height comes out to be 12. Okay, if height is 12, 5/4 of this will be what? 5/4 of 12. This will be 4 1s are 4 3s are 3 into 5, it will be 15. So this will turn out to be 15. So this is 15 and this is 12. Okay, what is being asked to me? What is the sum of the length and the height of the wall? Sum of the length and the height will be 15 plus 12. So 15 plus 12, 17, 27 will be the answer. Sum of the length and the height of the wall. Okay, that's how simple it is. So it was again a simple problem on rectangle, but it was given in terms of length and the height. So you will be confused whether it's 2D or 3D. It's obviously 2D. It is a rectangle that you had put it in terms of length and the height.